started.
Okay. So that I can have it for anybody else who wants to view it later. So we will go ahead and get started. So what I'm going to do, I took the midterm exam review and I printed a copy, and I'm just going to literally work through the entire thing on the computer, so you'll watch my writing. So my questions won't be identical probably to yours, but they will be extremely similar. And so remember, you can do the midterm review unlimited times to prepare yourself for the actual midterm. So if there's no questions, we're going to get started. So I think you can easily just, ask me a question by just saying something as I work through the problems. You can chat, but it'll be difficult for me to see your chat in time to answer your question quickly. So, yeah. Do y'all have any questions before we get started? All right. So I'm going to take this camera off. Okay. Alrighty. Clear the screen. Alright. Okay. So remember in this class, for all of the assessments, wait, can you still see my screen?
Yeah.
Okay, good. So remember, for all the assessments, you cannot use a calculator. So, I'm trusting you guys that you will, when you're doing your homework and practicing at home, please practice not using a calculator. You can certainly use it to check your answers, but you don't want for the test to be the first time that you are not using a calculator. So just kind of keep that in mind. Okay, so let's start with question number 1. So we're going to simplify the following expression. We have 2 plus 16 divided by 4 plus 7 times 4 squared. Okay, so for this type of problem, we're going to use order of operations. And the kind of easy way that we can remember what those operations are, we like to call that Pemdas. Or please excuse my dear Aunt Sally. So the P represents parentheses. The E represents exponents. M is multiplication. D is division. A is for addition. And S is subtraction. Okay, so something to keep in mind with order of operations is that multiplication and division have equal weight. You just do what comes first from left to right. And the same thing for addition and subtraction. They have equal weight in terms of the importance, but you do what comes first from left to right. So what that means is you don't always multiply before you divide. It depends on what you see first from left to right. So looking back at the problem here, we don't have any parentheses, so we skip down to exponents. So we have an exponent here, 4 squared. That's going to be 16. And I'm going to just go step by step by step. I'm going to write down everything else as we begin to solve this problem. Okay, so now, and my allergies are killing me, so I'm sorry if I'm sniffing throughout the video, but I forgot my Zyrtec this morning. Anyway, all right, so no more exponents. And remember, 4 squared is the same thing as 4 times 4, which is 16. Okay, so next we have, oh, thank you, multiplication and division. So again, it's based on what you see from left to right. So if we look left to right, we don't want to add 2 plus 16 because we're not ready for that yet. but we have division here, so let's take care of this. That's going to be 16 divided by 4 is 4. And so let's write down everything else. I'll make that a little bigger. Okay, so we have 2 plus 16 divided by 4, which is 4, plus, and now we have multiplication. So 7 times 16. So I'm going to write that down on the side because I don't know what that is off the top of my head. So 7 times 16 is the same thing as 16 times 7. So 7 times 6 is 42. I'm going to write the 2 and carry the 4. And then 7 times 1 is 7, plus 4 is 11. So we have plus 112. Okay, so now we've got 2 plus 4 plus 112, and it's all addition, so we can just add straight across. So 2 plus 4 is 6, plus 112 equals 118. And that's going to be our final answer. Okay? All right. What's the best way to do? I guess just do another one. Okay. Any questions here? No. All right. Okay. So let's look at question number 2. So we have to simplify 5 times 6 times 9 minus 52 plus 3 times 4 times 7 minus 18. So again, we're going to follow order of operations, which is please excuse my dear Aunt Sally or Pemdas. So now here we do have parentheses. So we want to simplify within each parentheses first. So within this first set of parentheses, what would I do first? I would have to do the multiplication first. So I have 6 times 9, which is 54. So I'm going to bring down everything else. Plus 3. And again, I have parentheses here, so I'm going to simplify inside the parentheses. So inside the parentheses here, I'm going to do multiplication first. That's going to be 4 times 7 is 28. And then minus 18. So now I'm still going to simplify within my parentheses. I'm still dealing with the P in parentheses in Pemdas. No, excuse me. Okay, thank you. All right, so now, first set of parentheses, 54 minus 52 is going to be 2. So I have 5 times 2 plus 3 times, now 28 minus 18 is 10. So now I have simplified within the parentheses because there's nothing to simplify within these parentheses. At this stage, the parentheses represents multiplication. So now I'm looking at multiplication and addition. So we're going to take care of the multiplication next. So 5 times 2 is 10, plus 3 times 10 is 30. And so now we could just simplify this and say 10 plus 30 equals 40. So 40 is your final answer there. All right. Okie doke. Let's keep the party going. Oh no! Don't freeze. Oh, okay. Let me blow my nose while it's breathing. Give me 1 second.
Just cancel it. Yeah, just cancel it.
You think so? Let's try it. Okay. We're going to restart. All right. Okay, hold on. Let's see here. Okay, do you see a blank screen now?
Yeah.
Okay. All right, let's get back started. Gotta love technology. Okay, question number 3. So we have 7 squared minus 6 squared divided by 7 minus 6 quantity squared. Okay, so again, order of operations. Order of operations is extremely important, and it's not going anywhere. You're going to be needing to use that all the way through really all of your math courses, whether you stop at college algebra or keep on going. Or when you go to, if you take MGS 1106 after this, order of operations is extremely important. So now, we don't have parentheses here, but we do have a fraction bar. So it's best when you have a fraction bar to simplify the top, then simplify the bottom, and then divide. Let's focus on the top. So we have 7 squared minus 6 squared. Let's take care of the exponents. So 7 squared is the same thing as 7 times 7, which is 49. And 6 squared is 6 times 6, which is 36. So we have 49 minus 36 divided by, now at the bottom, we've got 7 minus 6 in parentheses, so we're going to do that first, which is just 1, and then we have 1 squared. Okay, so the top now, 49 minus 36, so 49 minus 36, we line up like this, 9 minus 6 equals 3, 4 minus 3 equals 1. You can always double check your subtraction by adding back up to make sure you get your 49. So we've got 13 at the top in the numerator, and then 1 squared is 1 times 1, which is just 1. And so now we have 13 divided by 1. That's what this basically is saying. 13 divided by 1, which is 13. So 13 is going to be your final answer there. Okie doke. Okay. So number 4, we're looking at a prime factorization. So prime factorization. I know my handwriting is sketchy, but I'm doing the best I can. Okay, so we want to determine the prime factorization of 198. All right, so the way that I like to do this is I like to do what's called a factor tree. So I'm going to start with the number in question, and you want to break it down in what looks like branches by writing the number as factors. So you start off by thinking of any 2 numbers that multiply together to give you 198. So you want 2 factors of 198. So I don't know at the top of my head. I know one number for sure that is a factor, and that's the number 2, because 198 is even. So I know 2 will divide evenly into 198. So I can at least start with that. And so let's see, if I divide 2 into 198, let's see what the other factor would be. So 2 divided into 19, it goes in there 9 times, because 9 times 2 is 18, and then 19 minus 18 equals 1, and then I'm going to bring down the 8. And so now 2 goes into 18 9 times. 9 times 2 is 18, remainder of 0. So what this tells me is that 2 times 99 equals 198. So 2 times 99 would be a factorization of 198, but a prime factorization means we would only have factors that are prime numbers. And a prime number is a number that is only divisible by itself and the number 1. So 2 is a prime number, but 99 is not a prime number. You can divide other numbers other than 1 and into 99. So 99 is divisible by 9. 9 times 11 equals 99. And so you look at your numbers and see if you can continue that process. So 11 is a prime number. It cannot be divided by anything but 11 and 1. But 9 is not a prime number. 9 can be written as 3 times 3. And so now I'm done. I have all prime numbers here. 2, 3, 3, and 11. So the prime factorization would be 2 times 3 times 3 times 11. But we have repeated multiplication here. So 3 times 3 is the same thing as 3 squared. So really, my prime factorization can also be written as 2 times 3 squared times 11. And this would be your answer. So now, let's say you thought of 2 different numbers that multiply to give you 198. You would still end up with the same answer. So like, for example, let's say that you knew that 198 was equal to 18 times 11. And then you break down 18 into 3 times 6. And then you break down 6 into 2 times 3. Well, you still have those same prime numbers, 2, 3, 3, and 11. So even if you start with 2 different factors, you'll still get to the same correct answer. All right, and then in MAT0018, they tell you use exponents for repeated factors. That's what the blue represents, a repeated factor or repeated multiplication. All right, any questions about this one? Okay, let's keep going. All right, so number 5, you're graphing an inequality. So we have x is less than or equal to -2. Okay, so inequality symbols. This is less than. This is greater than. And then this would be less than or equal to. And this would be greater than or equal to. Excuse me. So, okay, so we're talking about a region of numbers. So we want to start with a number line. And so we only have one number that we're concerned about, and that's -2. So I'm just going to put that in the middle. Okay, so if I were to put some other numbers around -2, a number greater than -2 would be, for example, 0, or any positive number would be greater than -2. So I'll put maybe 0 here. In between -2 and 0 would be -1. And then numbers less than -2 would be -3, -4, and so forth. So the graph will look like this. So for less than or greater than, to mark our number, we would use open circle, because we are not including that number, but we're starting at that number. So if it's less than or equal to or greater than or equal to, we use a closed circle. So for this problem, we're going to use a closed circle over -2. And then now we have to shade. So this says x is less than or equal to -2. So all of the values less than -2 are going to be to the left. So we're going to shade everything to the left all the way to the end of the number line. And this arrow means it technically keeps going, but we can't write every single number in the universe, so just do an arrow. And that's how your graph would look. Now, if your x is on the left-hand side, yes, you can totally follow the direction of the sign. But if your x or your variable is not on the left-hand side, then you don't want to just follow the direction of the sign. Excuse me, y'all. And that is your graph of this inequality. All right, so I'm going to stick number 6 right here, just to kind of keep the problem still up there. So now we're going to compare integers. So we have -7 and +3. And we're going to use less than, greater than, or equal to in the box. So -7, that's a negative number. Remember I said any positive number. So if I were to keep going here, this would be 1, this could be 2, this could be 3. So -7, which would be somewhere down here, -7 is definitely less than 3. So we would use this symbol here. So you just want to be familiar with your inequality symbols like this. All right? Okay, let's keep going and let's practice operations with integers. That basically means we're including negative numbers now. So number 7, we have -6 plus 1. Okay, so adding integers. So some rules here. So when we are adding integers, that means positive and negative numbers. When you have the same sign, you add and keep the sign. Okay? When you have different signs, you subtract and take the sign of the larger number. Hope you can read that. Okay, so right here, -6 plus 1. This is negative, this is positive. So we have different signs. So we have different signs. Ignore the signs right now and just subtract 6 and 1. So if we subtract 6 and 1, that's going to be a 5. But then the 6 and the 1, which one is bigger? The 6 is bigger. And what's the sign of that 6? Negative was going to be -5. And it may help you to take the sign first and then subtract. So again, negative, positive. So we have different signs. Go ahead and grab the sign of the larger number, which would be that 6. So we're going to grab that negative and then just subtract 6 and 1. If we want to look at that on the number line, so we'll put -6 here. And let me see. So -6, here's -6 plus 1. So plus 1, we go 1 to the right. We would end up right here at -5. But your answer is -5. But these are your rules for adding integers. Okay? All right. The next one, we're going to divide or multiply. So number 8, we've got negative 12 divided by negative 3. Okay, so when you multiply or divide integers, when they are the same signs, the answer is positive. If they are different signs, the answer is negative. So, negative 12 divided by negative 3, and that's what this is telling us. It's negative 12 divided by negative 3. Okay, so those are the same signs, so that means that our answer is going to be positive. And what's 12 divided by 3? That is 4. So the answer is going to be positive 4. Just so we're clear, if it was negative 12 divided by positive 3, those are different signs. So it would be negative 4. Okay? So remember those adding. Oh, and then one more thing. Well, we'll see it. Yeah, I'll wait. We'll see it. Okay. So number 9. Let me check. Okay. All right. Sorry, just check the chat room real quick. Okay, so number 9, 11 plus 54 divided by 6 minus 3 times 2. So we have more order of operations. So let's throw that, please excuse my dear Aunt Sally up there. We don't have parentheses to address, so we're not going to worry about that. We don't have any exponents, so we're not going to worry about that. Now we have multiplication and division. Let's go left to right. We've got division here. So 54 divided by 6 is 9. And it would really be helpful if you guys, knowing your times tables is extremely helpful in this class, by memory. So if I were you, I would practice that. So whether that is get that kind of hundreds chart and practice those multiplication tables, or get you like flashcards, or they have apps now where you can practice that. I strongly encourage you to just get more comfortable with your times tables. Old school, 9 times 6, 9 times 5, 9 times 4, that type of thing. Okay, so now we have more multiplication. Now, the sign in front of the number goes with that number. This is going to be negative 3 times 2. Okay? So negative 3 times 2. We are multiplying. They have different signs. Your answer is going to be negative. So 3 times 2 is 6. So negative 3 times 2 is negative 6. Okay, so now we have 11 plus 9 minus 6. And we have addition and subtraction, so we just do it first from left to right. So 11 plus 9 is going to be 20. And then 20 minus 6 equals 14. 14. And just to remind you, so 6 minus 0, can't subtract that, so we're going to borrow from the 2, make this a 10. 10 minus 6 is 4, then bring down the 1. So 14 is your answer. All right. What are you doing in time? Okay. Okay, 10. Negative times the absolute value of 56. Okay, so absolute value. Absolute value is describing the distance of the number from 0. And so, long story short, the absolute value of the number is going to be positive. So let's deal with the absolute value part first. Absolute value of 56 equals 56. Okay? Absolute value of 56 is 56. Absolute value of negative 56 is 56. Because again, what that is saying, if this is 0, let's say this is 56, that's negative 56. If you were to measure the distance from here to here and here to here, they would both be 56 units, or a distance of 56. So the absolute value of both of these numbers is positive 56. So here, do the absolute value first. So the absolute value of 56 is 56. But then we have a negative out here. So negative times 56 is negative 56. So the main thing here, remember this. Negative times the absolute value of 56 is negative 56. The absolute value of negative 56 is positive 56. That's basically what this problem is trying to see if you know. Alright? And the reason why it's different is because you do the absolute value first, and then you multiply it by the negative. There's no negative in this last one down at the bottom here. There's no negative on the outside, so the absolute value of negative 56 is positive. This is so awkward. All right. Let's keep the party going. Okay, number 11. Negative times 10 minus 8 minus 1 minus 11. Okay, so let's follow order of operations. So we're going to take care of the parentheses. So I have 10 minus 8, which is 2. So I have negative times 2 minus, and now we have another parentheses, 1 minus 11. So 1 is smaller than 11, number 1. So if we take 11 away from 1, we're going to be in the negative. Something else to remember when you're subtracting integers. When subtracting, you can add the opposite and then follow the adding integers rules. So 1 minus 11 can be written as 1 plus negative 11. Okay? That's what adding the opposite means. So we have different signs here. Positive 1, negative 11. So the answer is going to be a negative because the 11 is bigger than the 1. And the difference between 11 and 1 is 10. Let me write that a little better. We have negative times 2 minus negative 10. So notice that this minus here is this one here. Okay? This negative in the parentheses comes from 1 minus 11. So now let's continue to simplify. So at this point, we have subtraction here, and then we have minus times negative 10. So a negative times a negative is a positive. So minus negative 10 is going to be plus 10. Okay? And so now let's bring down that minus 2. We can get rid of the parentheses because a negative times positive 2 is just negative 2. So now we have negative 2 plus 10. So again, we have different signs. So take the sign of the bigger number, which in this case would be the 10. So it's going to be a positive. And the difference between 10 and 2 is 8. So 8 is going to be your final answer here. Okay? All right.
I do have a question. I'm sorry.
Yeah. No worries. Go ahead.
Okay. This is Sylvia. By the way. Hi.
Hi.
Hi. Nice to meet you.
You too.
Now the 10. Thank you. The 10 and the 2. Why wouldn't we multiply them by each other? And
at this point here, up here.
Okay.
Where are you thinking you would multiply?
Below that. So you see how you put both of them in parentheses? It almost appeared as though you were multiplying both of them into each other. So I was thinking immediately 2 times 10 for some reason, and then I would have got a negative. So if I would have multiplied those two, I would have gotten, what, a 20, and I would have put negative 20.
The reason why you don't multiply is because of this subtraction in the, this subtraction here. So you're taking all of this minus all of that. So negative 2 minus negative 10. Negative 2 minus a negative is actually just plus. So then we have negative 2 plus 10.
Got it.
Cool?
Okay. Thank you.
No problem. No problem. Thank you for asking.
Of course. Thank you.
All right. Let's look at number 12. Okay. So, absolute value. No, that's not absolute value. I can't see. That's a bracket. Negative 10 plus negative 15, close bracket, plus 6 plus negative 13, close bracket, plus negative 3. Okay, so don't be thrown off by brackets. The only reason why you have brackets here is because you typically don't want to use parentheses. You don't want to use double parentheses. So it just looks better if you already have parentheses in an expression, but you need to enclose something that has parentheses. People tend to then use brackets to kind of make it look clearer about what you are grouping. So for order of operations, parentheses in this case would be the bracket. Because parentheses just means grouping. So sometimes you group things with parentheses, sometimes you group things using brackets. You group things when you have the division bar. So, okay. So here, I'm going to work within this first group. So, negative 10 plus negative 15. So we are adding these integers. They have the same sign, so we're going to keep the sign. So that's going to be negative, and then add 10 plus 15, which will be 25. All right? And so I don't need the bracket because the bracket was only there to make sure we knew to do everything in that bracket first before we combine it with anything else. And same thing with this bracket, 6 plus negative 13. So we have different signs. So we're going to take the sign of the larger number. So I'm going to bring down this plus sign just so we don't forget it. So I want to bring down, never mind. Okay, so now 6 plus negative 13. So they're different signs. We're going to take the sign of the larger number, which would be that 13. So the answer is going to be a negative something. And then we just find the difference between 13 and 6, which would be 7. Now, since I have plus a negative, I am going to put parentheses just because it looks better. It's not like required, but it looks better if you have two signs side by side together. And then now I have plus that -3. Okay, so now let's see what we're going to do. So really we have addition all the way. We have -25 plus -7 plus -3. So if we look, we're adding, let's just, since they're all negative, we could kind of do it all at one swoop, but I'm going to do it step by step. So if we add the first two, -25 plus -7. So they are the same sign. So I'm going to keep the sign, and I'm going to add 25 plus 7. So 25 plus 7. 5 plus 7 is 12. Yep. Carry the 1. And then 1 plus 2 is 3. So -25 plus -7 is -32. Then I have plus -3. So again, I have the same sign. So we have -32, -3, and we're adding. So we're going to keep the sign. It's going to be negative, and then we add 32 plus 3. 32 plus 3 is 35. So the final answer is -35. -35. Okay. (13), we have parentheses. 1 divided by -2 raised to the second. Okay, so, yay! Okay, thanks. I'm glad it's getting easier. That's why I'm here. Okay, so we have 1 over -2 squared. So you could do this a couple of ways, and I probably should look at how the book says it, but I'll show you both ways. Well, I'll show you both ways. Okay, so one way to do it is to remember that so the exponent here is telling you how many times you are multiplying the base. So what's in parentheses is your base in this case. So that is telling you we're doing 1 over -2 times 1 over -2. That's what you're doing. So when you multiply fractions, you can just multiply straight across. So that would be 1 times 1 at the top, and then -2 times -2 in the bottom. So 1 times 1 equals 1, and then -2 times -2 is +4. They have the same signs. We're multiplying, so the answer is going to be positive. So that's your answer there. Another way you could do it is to use your exponent properties, which I may be jumping ahead here, and if I am, my bad, but I'll just show you. So you can raise the 1 to the second power and the -2 to the second power. And so 1 to the second power means 1 times 1, and -2 to the second power is -2 times -2, which again gives you that 1 over 4. So these are two different ways of tackling the same problem. I think the top part is more how the book describes it, but I gotta be honest with you, I'm teaching a few classes, and you only go to certain points in each class, so I sometimes kind of mix up how far, I need to explain. So sorry if I gave you too much information. But the answer is 1 over 4. It's going to be the most awkward video. Like, this teacher is a mess. Okay, so that's 13. Let's look at 14. We're comparing decimals now. Thank you. Y'all are so sweet. Okay, so we've got 21.204 compared to 21.28. And we want to choose less than, greater than, or equal to. Okay, so decimals. When you're comparing decimals, first off, start from the, look at the decimal point, and then from the left, they both are 21 point something. So ignore that. Like, that's not going to help us compare anything. Okay, now we've got focus on the decimal part here. When you're comparing decimals, you want for them to have the same decimal value, like the same number of decimal values. So 0.204, that's 3 decimal values. 0.28, that only has 2, so we really can't properly compare it. So let's make them both have 3. So 0.28, if we put a 0 here, that's not going to change the value at all. All right? 0.280, the same thing as 0.28. Same thing. So now you can compare. And let's just ignore the decimal and let's just compare 204 to 280. So 204 compared to 280, is it 204 is less than 280, greater than, or equal to? Definitely not equal to. And 204 is less than 280. So that means that 21.204 is less than 21.28. It's the same thing as 21.280. So it's tricky. So, you know, if you don't make them have the same number of decimal places, you'll think you're comparing 28 to 204. But you're not. You're comparing 204 to 280. All right? The answer is less than. The answer is less than. Okay. Number 15, we're going to round 0.64 to the nearest tenth. Okay, so the nearest tenth will be the first number after the decimal. And so you want to remember that place value chart. So if we're rounding this spot in the red, we look to the right. And if the number to the right is 0 through 4, we would keep the number in red the same. If the number to the right, this blue number, is 5 or higher, we round the 6 up. So in this case, that would be 0.6. Okay? So remember your place values. So we've got we've got tenth, hundredth, thousandth, and so forth. And then from the left, we would have 1, 10, 100, 1,000. So I'm using shorthand here, but the main thing is to be familiar with these place values. And then you always look to the right to determine how you round that certain place value. And if it's 0 through 4, you keep it the same. If it's 5 and up, you round up. So that's your answer here, 0.6. All right. Okay, 16. We have negative 1.953 minus 6.6. Okay. So we're subtracting, so you can change, excuse me, you can change this to add the opposite, but I sometimes just look at it at this point. We have the same sign, negative, negative. So this is basically, you could do negative 1.953 plus negative 6.6, that's the same thing. And so we're adding two numbers with the same sign. So we're going to keep the sign. So keep the sign. And then we're going to add 1.953 to 6.6. So I'm going to do that on the side here. So 1.953 plus 6.6. When you're adding decimals, you want to line up the decimal values, decimal points. And so I like to put zeros because I'm kind of messy, so I need to kind of put placeholders in there because I'll get lost in my handwriting. And so now we just add like you would normally add whole numbers. So 3 plus 0 is 3, 5 plus 0 is 5, 9 plus 6 is 15. Yeah, carry the 1. And then 1 plus 1 plus 6 is 8. All right, so your answer is going to be negative 8.553. Not negative, it's so big. Okay, so it's negative 8.553. Okay? Alright, well, I think I can do 17 right here. So 17, we're simplifying negative 6.79 divided by negative 0.7. Okay, so first determine what your if it's going to be negative or positive. So we're dividing numbers, they have the same sign, so the answer is going to be positive. So the quotient, which is the answer to a division problem, is going to be positive. So we cannot even worry about those signs anymore and focus on the division. So so now we have 6.79 divided by 0.7. Okay, so now 6.79 divided by. So this is going to go in the division box. 6.79, and then the divisor 0.7 is going to go out here. Okay? Alright, so now when you're dividing decimals, so the divisor has a decimal place, so we need to move this however many times to make this a whole number. We want that 0.7, we want to think about it as 7. But if I move the decimal here one time, I have to move it here one time. So that means that the decimal in our quotient is going to be right here. So now it's time to do our long division. So you say 7, and I can rewrite it if you want. We have 7. I want black. So now we have 7 divided by 67.9 decimals here. That's what we have. Maybe some more space. Let's see if I can drag it. Okay. Well, let's see how much space I need. Okay, so now 7 cannot go into 6. The 7 can go into 67. So 7 times 7 times 10 is 70. 7 times 9 is 63. Yeah. So 7 goes into 67. 9 times 7 is 63. And then we're going to subtract 67 minus 63. is 4. Bring down the 9. Good, I'm running out of space, but I think we're almost done. 7 divides into 49 7 times, because 7 times 7 is 49. When we subtract, we get 0. So, your answer is just 9.7. Now let's go back. We just said the answer is going to be a positive number. So the answer here is going to be positive 9.7. Okay? 9.7. Sorry, I got a little messy here. Any questions about that one? Okay. All right, 18. 9.6 minus 7.5 plus 12.6. So let's revisit order of operations. So all we have is subtraction and addition. But remember, these are equal importance, depending on what comes first from left to right. So that means we're going to do this first, okay? So we have 9.6 minus 7.5. When you subtract decimals, you line up a decimal point. So 6 minus 5 is 1. Bring down the decimal. 9 minus 7 is 2. So we have 2.1 plus 12.6. And so now, again, we add decimals. We line up the decimal point. I like to put the bigger number on the top. So 12.6 plus 2.1. The decimal value stays in that same spot. 6 plus 1 is 7. 2 plus 2 is 4. And bring down the 1. So your answer will be 14.7. So if you had added negative 7.5 plus 12.6, you would have gotten the answer wrong. If y'all are on social media or Facebook, sometimes they have those order of operations problems that go viral where everybody's arguing what the answer is. It's really just order of operations. And a lot of people learn and sometimes are taught incorrectly that you have to follow this order no matter what. And that's wrong. Once you get to the multiplication, division, addition, subtraction, it's based on what's first from left to right. So it's kind of interesting and scary how many people on my Facebook who thought they knew, or they said they were taught that it always goes in that order. But that's okay. We are going to fight that and help save the world order of operations. Okay, so I know it can. I know. Hopefully I'm helping that. But I know. Oh, goodness. I'm reading the chat. That's what I'm not talking to myself. Well, I am, but, you know. Anyway, some of y'all are chatting with me, and it pops up. So, I know I'm crazy. I'm crazy. Okay, so 19, more order of operations. So, let's work with parentheses first. So we have 4.6 plus 7.22. I'm going to write them vertically. Easier for me to add. 4.6 plus 7.22. You have to line up those decimals. So I like to put a 0 just to kind of help me line everything up. So 0 plus 2 is 2. 6 plus 2 is 8. Bring down the decimal. 4 plus 7 is 11.
So the answer would be 11.82.
Okay. So now I have 14 minus 11.82. Okay, so now I'm going to line that up vertically. 14 minus 11.82. Okay, so the decimal in the 14 would be right here. I'm going to put zeros there as placeholders. Okay, so now we have a lot of carrying to do. So 2 minus 0, I can't do that. So I'm going to borrow from the 0, but I need to borrow from this 4. This is going to be 3. This is going to be 9. This is going to be 10. Okay? And so what happened here, and this is really weird, and I'm going to be really honest with you guys, I have a hard time, like, explaining why. But, so, when you first borrow the first thing, and we're looking here. We're trying to borrow for this first 0. We borrow from the left. Right now, the left is like a 10, because you have a 0 there, but as if it's 10. Think of it kind of like a 10. If you borrow from that 10, that makes this become 9. So when you borrow from this place here, you're creating the 10 with the first column, but by borrowing from the second one, it makes it a 9. And because it's a 10 here, just like you have to borrow from the 4. So I always feel like I don't explain that well, but
yeah, it's confusing.
Does it make sense? Y'all yell at me if it doesn't make sense.
It's confusing.
Yeah, I know. Let's see. So just know that if you, when you have multiple zeros, it gets confusing for me as well. So when you start off, you have the 0, you borrow from this way. Because it's a 0, it becomes a 9, not a 10. And because it's a 0, you had to then borrow from this place. So this becomes 3, this is a 9, and this first one is a 10. So 10 minus 2 is 8. 9 minus 8 is 1. Bring down the decimal. 3 minus 1 is 2. And then 1 minus 1 is just 0. So your answer is 2.18. Any questions about that one? Okay. All right. Oh, here we go. We're doing so well. All right. Okay, let me pull up again. Is this page? No. Okay. And okay, so we are on 20. So 70% is equivalent to what simplified fraction? Okay, so 70%. So remember that you could do this a few different ways. So you could go from, you could remember a percent means over 100. So this is the same thing, 70% is the same thing as 70 over 100. And then if you're simplifying it, if you look, so these 70 and 100, you can reduce that into 7 over 10. That's a cool trick when you have zeros like that on the right side. You can reduce it by canceling out however many zeros they have in common. And 7 over 10 can't be reduced further, so that is your final answer. Another way you could do it is to take the 70% and change it into a decimal. So to go from a percent to a decimal, I like to write it like this. So the decimal to percent and percent to decimal. You move 2 places. Which way do you move? If you're going from decimal to percent, you move 2 to the right. To go from percent to decimal, you move 2 to the left. So if I want to go from percent to decimal, then I could say, all right, that's 70%. The decimal is here for 70. If I move 2 to the left, that's going to be 0.7. That is equal to 70%. And now, 0.7 as a fraction. Well, what place is the 7 in? That's in the 10th place. So 0.7 is the same thing as 7 over 10. So you can get to this answer 2 different ways. So I just wanted to show you both. But we're going to do more with percent now. So 21 kind of is going in the other direction. So 21 says that 0.6 is equal to what percent? So now we want to go from decimal to percent. So you move 2 places to the right. 1, 2. So the answer would be 60%. All right. Another way you could do it is if you like multiplying decimals, you could take 0.6 and multiply it by 100. And that will get you your 60, and it will be 60%. There's 2 different ways you can do it. I personally like the easier way, so I remember D comes before P in the alphabet. So all I have to do is remember I'm moving 2 places. Which direction I'm moving in depends on my little drawing here. Decimal to percent, 2 to the right. Percent to decimal, 2 to the left. All right? Okay, so 22 is now asking you to, so it says 200 is 40% of what number? Okay. So the way that I like to do these problems is to use proportion. And I want to quickly remind myself how the book goes through it. So I don't like to confuse you guys. One sec. Doesn't really say. Okay. All right, I'll tell you my way. Okay, so I set up a proportion. So we've got, so remember that percent means it's over 100. Okay? And the percent is talking about, so 100% is considered the whole, right? So that's why we have 100 here at the bottom. That's like your whole value, the entire thing. And then the percent is the part of the whole. So like let's say the whole is 100. If 50% of 100 is 50, then 50 is the part and 100 is the whole. Or what if I say, let's use something small like 10. So 50% of 10. Well, what is that? Well, I'm using these numbers because, hopefully we remember that 50% just means half. And what is half of 10? 5. So if I wanted to set this up as a proportion, 50% over 100 is equal to the part of 10, which is 50%. So 5 over 10 is equal to 50% over 100. It's a proportion. It's proportional to each other. So the top part, I think about it as that's the part, and then the bottom is the whole. When you do problems like number 22, it's going to say 200 is 40% of what number. So when they say of something, that is telling you that is the number that's in the bottom. Okay? That is the number that's in the bottom of your proportion to solve a problem like this. So let's set this up using this information. So again, it's all, your percent is always going to be over 100. This 100 here is always here. What varies is the percent number and then the part and the whole on the other side. So over here, 200 is 40% of what number? So if I set up my proportion, this is always 100. The percent number at the top is going to be either what they tell you or maybe what you're trying to find. In this case, it's what they tell me. They told me that it's 40%. So I'm going to write this as 40. If I can get my pen. 40. Okay? So now it's equal to what other ratio? So it's the part over the whole. And I remember I told you of what number, whatever they say after of, that is considered your whole. So in this case, we don't know what that is. So I'm going to say that is X. I don't know what that is. And then the part is going to be the other number, what they're saying the part is. So they're saying that 200 is the part, or the 40% part, so that's going to go up here. So what I'm doing, I'm setting up a proportion to help me solve this type of problem. And the beauty of this proportion is that it works no matter what you're solving for. You fill in what you know, and you solve for what you don't know. So we're about to solve it, but I just want to see if this makes sense so far. Are there any questions so far? All right, so let's solve it now. So to solve a proportion, we're going to cross multiply. And actually, before we do that, let's simplify some of this. 40 over 100, we can reduce that down to 4 over 10. And actually, we can reduce that further. 4 over 10 can be reduced. 4 and 10 can both be divided by 2. So this can be 2 goes into 4 2 times, 2 goes into 10 5 times. That's going to make this problem be easier to solve because the numbers are now smaller. So now we're ready to cross multiply. So we actually have 2 times x. I think I may be teaching ahead, but you know, it's okay. Equals 5 times 200. And I'll just write it out like that. Okay? And so 5 times 200 is going to be 10, and then 2 more zeros is going to be 1,000. So I have 2x equals 1,000. And so now I'm going to solve for x by dividing by 2. And so x equals 10,000 divided by 2 is going to be 500. Okay? Now, it's helpful when you solve these percent problems to think about what if your answer makes sense. So we just said that 200 is 40% of 500. So does that make sense? I think it does, because half, 50% of 500 would be 250. So 40% would be a little less than 250. So this is going to be your answer here. But this proportion setup works for any type of percent problem where you're finding either the whole, the percent, or the part value. And just to summarize, it is the percent over 100 equals the part over the whole value. And a hint, it's always the thing after the word of. Okay? So I personally think that's helpful because it makes these become, you do the same thing every time. It's just what you solve for changes. Let me see, there's another one that we do that for. I don't think, but yeah. Okay. So let's go for 23. I'm going to go a little over time, but I'm going to finish the review. So if you have to head out, I'm going to post this video shortly. Okay, 23. So let's see here. Molly completed, completed 7/12 of her homework. I can't write. And Matt completed 9/15 of his homework. Who completed the most? Molly or Matt? Okay. So now, since we're not using a calculator, we're not going to just divide and compare the decimals. Unless you just like to divide numbers and compare decimals, you could totally go that route. You could do 7 divided by 12, get the decimal, 9 divided by 15, get the decimal, and compare. I'm going to use a number line to compare these. So let's see. Let's say 0 to, okay. Now first, let's simplify these fractions if possible. So 7/12 can't be simplified, but 9/15 can. 9 and 15 can both be divided by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. So 9/15 is equal to 3/5. Okay. So let's start off by getting an idea of where 3/5 would be. I'm going to divide 0 to 1 into 5 equal parts. Let's see. 1, 2, 3, 4, 5. Okay. This is 1/5, 2/5, 3/5, 4/5, and that's 5/5. Okay. So 3/5 is going to be right here. And remember, that's the same thing as 9/15. Okay, so 7/12. So if we were to think about 7/12, let's see, if that's close to 6/12, which would be half. So I'm going to try to divide this. Let's see, this would be 1. One, 2. Wait. third would be here. Start it. You put that into thirds. So this would be 1/3, 2/3, 3/3, 1/6, 2/6, 3/6, 4/6. Okay. And then that would be, okay. So this would be 1, 6, 2, 6, 3, 6. Probably shouldn't be on the same number line. That's going to be confusing. Let me not use the same number line, because that is going to be confusing. So I am doing these in real time with you guys. So let me, oh no, I need more room. How do I get my room? More room. Darn it. Let me try something. No, I don't want to save. Oh. Johnny, what are you doing? I'm doing the most here, but okay. So view, zoom in. Okay. And what were the numbers? Probably would have been quicker to do the decimals now that I think about it, but that's okay. So 7/12, and then 9/15. Okay, so now I'm going to use the same value. Okay, so I've got, let me start by doing thirds, and then half of the thirds, and then half, that'll be 6, and then I'll divide in here. Okay, so this was 1/3, 2/3, 3/3. I divided the thirds into 6. 1 6, 2 6, 3 6, 4 6, 5 6. I divided the 6 into 12. I divided each little section here. So this is 1 12, 2 12, 3 12, 4 5 6, 7 12. Oh, how annoying. Okay. So let's change it to decimals then, because these are really close. So this is good. Sometimes this is a learning process for you guys. So I was trying to compare using the number line, but they're so close because my drawing is not drawn to scale. So it is probably going to be best to go ahead and get those decimal values and compare them that way. Because the way my drawing is set up, it's so close, it's hard to compare them. So plan B, let's compare by getting decimal values. So 7 divided by 12 is 7 divided by 12. So 7 division 12. So 12 can't go into 7, but if I were to add a 0 here, put the decimal, 12 can go into 70. So 12 goes into 70. How many times? Let's see, 12 times 5 is 60. So that's the biggest number it can go into 70. 5 times 12 is 60. And subtract, and then bring down a 0. And then 12 goes into 100. Let's see. 12 times 7 is 84. Right? Yeah. Yes. 12 times 8, 84 plus 12, 96. 8 times 12 is 96. Subtract, and we get 4. Let's get one more value and see what we get. 12 goes into 40. 3 times, because 3 times 12 is 36. Let's stop there and see what happens with the 9 over 15. Okay, so now we have 9 divided by 15. All right. So we've got, and you could have reduced it, what was that, 3 over 5? We'll keep it like that. So 9 divided by 15. So again, we're going to put the decimal here, but add a 0 so we can divide 15 into 90. So 15 times 2 is 30, times 4 is 60, times 6 is 90. 6 times 5 is 30, 0 carry the 3, 6 times 1 is 6, plus 3 is 9. And that was the way to go. All right. That took way longer than necessary. Okay, so now, very easy to compare. So 7 over 12 equals 0.583, and 9 over 15 equals 0.6. Now remember, if we compare decimals, let's make them have the same number of decimal places. Let me put 2 zeros here. So now I'm comparing 583 compared to 600. So 600 is greater than 583. So 583 is less than 600. So that means that 7 over 12 is less than 9 over 15, because 583 is less than 600. So I took the longest route ever to explain that, but hopefully that was helpful to you guys. I didn't lose all of you along the way, but that would be the best way to compare these. So yeah, any questions about that? Okay, good. All right, so almost done. What number was that? 23? Okay. Keep going here. 24. Simplify 3/4 minus 4/7. Okay, so when you add or subtract fractions, you must have a common denominator. We do not have the same or common denominators, so 4 and 7 a common multiple would be a number that 4 and 7 can both divide into. It's best to get the lowest common one, but even if it's not the lowest, you can simplify it later. So I can use a common denominator of 28, because 28 is a common multiple between 4 and 7. So to get 28, 4 times 7 is 28, but I have to multiply the top and bottom by that 7 so that I will keep equivalent fractions. So 3 times 7 is 21, and then now here to get 4 over 7, an equivalent fraction with the denominator of 28, I'm going to multiply the bottom by 4, because 7 times 4 is 28, but I have to do it to the top as well. So 4 times 4 is 16. So now I have 21 over 28 minus 16 over 28. So I'm going to keep that denominator that I worked so hard to get, and then combine the top, 16. And so 21 minus 16. So 1 minus 6, I'm going to have to borrow from the 2. So I have 11 minus 6, which is 5. 1 minus 1 is 0. So the answer will be 5 over 28. And it says to write it as a reduced fraction, so make sure that you have reduced this all the way. And we are good here because 5 and 28 don't have a common factor. So 5 over 28 is going to be your final answer. 25, we've got negative 5 over 9 minus 1 over 2. So here we have the same sign, so we're going to keep the sign and then add 5 over 9 plus 1 over 2. So that's the same thing as saying negative 5 over 9 plus negative 1 over 2. You have the same thing, so we keep the sign, and now we just need to add the fraction. So now we want to get common denominators. So we're going to use 18 as our common denominator. So how do I get 18? To get 9, to take 9 to 18, I'm going to multiply it by 2. We'll have to do it at the top as well. So 5 over 9 is equal to 10 over 18. And to get 2 to become 18, I multiply by 9. We'll have to do it at the top as well. So now I have 10 over 18 plus 9 over 18. I keep that denominator, and then I combine the top. So my answer is going to be negative 19 over 18. Okay? Alright, so now dividing. When you divide fractions, you're going to change it into a multiplication problem, because when you divide fractions, you multiply by the reciprocal, or you do what I call keep, change, and flip. But since we have a negative here, let's go ahead and determine if our answer is going to be positive or negative. So a negative divided by a positive is going to give me a negative answer. So now I'm going to deal with that 4 over 9 divided by 10 over 11. So that's going to be, keep means keep the first fraction the same. Change means change division into multiplication. And then flip means you literally flip over the fraction. So 10 over 11 will become 11 over 10. Now, I personally find that it's easier to simplify and reduce at this stage before we multiply together. So we look up at the top and the bottom. So like 4 and 10, they have a common factor of 2. 4 can divide into 2 can divide into 4 2 times. 2 divides into 10 5 times. Okay, 9 and 11 don't have a common factor. So now I can go ahead and multiply. And remember, when you multiply straight across. That's going to be 2 times 11 over 9 times 5. And so 2 times 11 is 22. 9 times 5 is 45. But remember, I said earlier it's going to be negative answer. So the answer is going to be negative 22 over 45. Okay? All right. So now, 27, we've got 5 over 7 plus 8 over 9 times 1 over 2. So we're going to use our order of operations again. So we don't have parentheses, exponents, but we have multiplication. So we want to take care of that multiplication before we deal with any addition or subtraction. That's going to be here. So we are multiplying two fractions. So we can, at this point, let's go ahead and reduce if we can. So 8 over 2. 8 and 2 can be divided by 2. So 2 goes into 8 4 times. 2 goes into 2 1 time. So now we have 4 times 1, which is 4, over 9 times 1, which is 9. So now I have 5 over 7 plus 4 over 9. I don't know why that's so not lined up. Let me write that better. 5 over 7 plus 4 over 9. Okay, now we're adding fractions, so we have to have common denominators. So, let's see here. I think 63 is going to be the least common denominator, because 63 is a common multiple between 7 and 9. And yes, sometimes a shortcut can be to just multiply the denominators to get a common multiple. It may not be your lowest or your least common multiple, but it will be a common multiple to help you get to your final answer. So you may have to simplify on the tail end, but multiplying the denominators can get you closer, can get you a common denominator. Okay, so now 7 times 9 is 63. So I multiply the top by 9 as well. 5 times 9 is 45. And then 9 times 7 is 63. So multiply the top as well. So we have 4 times 7 is 28. And then now I'm going to have 45 plus 28, all divided by 63. So 45 plus 28. 5 plus 8 is 13. Carry the 1. 1 plus 4 is 5. Plus 2 is 7. So my final answer will be 73 over 63. And we do not have a common factor between 73 and 63. So that would be your final answer here. Okay, we are in the home stretch. We're finishing strong with fractions. Save the best for last, right? Okay. And we are freezing. He's tired. I know. I just want to make y'all laugh. Okay. Oh, she closed all the way. Okay, let me... Hold on one sec, guys. This is what... Just so you guys know, I am literally... Oh, you can't see it. Hold on. I am... literally working through a real final exam. Oh, wait. Yeah. I am literally working through a real midterm exam review. This is what I'm getting it from. So I'm just writing it. I couldn't figure out a way to show it and write at the same time. So that's what I'm doing. Just so you believe me, I am working through what you will work through, which is different versions. Okay, let me pull up my paint, and we're going to finish this up. Okay. Okay, 28. So we've got 5 over 2 minus 1/3 squared. Okay. All right. So let's take care of the exponents first, because that is required in my order of operations. So, all right, this is a good one here, because the base for this exponent of 2 is 1/3. So minus 1/3 squared is 1/3 times 1/3. Okay? So now I have multiplication to take care of before I deal with the subtraction. So 1/3 times 1/3 is going to be 1 times 1 over 3 times 3, which is going to be 1 over 9. That's going to be 5 over 2 minus 1 over 9. So now I'm subtracting fractions, so I need to have a common denominator. So I'm going to go with 18. because 2 times 9 is 18. 18 is a common multiple between 2 and 9. So, okay, what is that? All right, 2 times 9 equals 18, so I have to multiply the top by 9 as well. So 5 times 9 is 45. 9 times 2 equals 18, so I have to multiply the top by that as well. 1 times 2 is 2. So now I have 45 minus 2 divided by 18. And 45 minus 2 is 43 divided by 18. And that's going to be my final answer. Okay, I know I'm working fast, but I'm going to post this for you to look at again if you need. Okay, 29, negative 4 over 9 minus parentheses 3 over 4 plus 2 over 3. Okay, so again, order of operations. Okay, thank you. So I'm going to work in my parentheses first. So in the parentheses, I need to get common denominators because I'm adding fractions. So let's use 12 because that's the least common denominator between 4 and 3. So I'm going to multiply the first fraction by 3 over 3. It's going to be 9 over 12, and the second fraction by 4. That's going to be 8 over 12. And so that equals 9 plus 8 over 12 equals 17 over 12. So now I have, I went all out of order. Okay, negative 4 over 9 minus 17 over 12. Okay, so now I need to get common denominators again because I am subtracting fractions. And also, let's think. So before we even do that, we have the same signs here. So my answer is going to be negative, and I'm going to just add up 4 over 9 and 17 over 12. So 4 over 9 plus 17 over 12. I'm going to get common denominators. So I am not going to multiply 9 and 12. It's going to give me a really big number. It will work, but let's get the least common multiple. So if you think about multiples of 9, that would be 9, 18, 27, 36. And if you think about multiples of 12, that would be 12, 24, 36, 48. The least common one would be 36. Let's use 36 so we can get a reduced fraction for our answer. So 9 times 4 equals 36. So my equivalent fraction to 4 over 9 will be 16 over 36. Then 12 times 3 equals 36. So 17 times 3, 7 times 3 is 21, carry the 2. 3 times 1 is 3, plus 2 is 5. 51 over 36. And so now I'm going to keep the denominator and add the top. 16 plus 51 is going to be 67. All right? So remember, right here, we said the answer is going to be negative, and then you just add up the fractions. So the answer is going to be negative 67 over 36. That was kind of messy. I'm not crazy about how that looks, but you just make that a little better to see. Okay. All right, Johnny, just chill out. Okay, so again, just to kind of summarize, I felt like I was kind of all over the place. So I worked in the parentheses first. I got common denominator of 12 and got 17 over 12. Then I have negative 4 over 9 minus my fractions I got, 17 over 12. Well, when you are subtracting integers, remember that's the same thing as adding the opposite. It's the same thing as that. So because we have the same signs, we kept the sign and then just added, these fractions here. And so when we added the fractions, we had to get common denominators. Again, we use 36 because that's the least common multiple between 9 and 12. And then we ended up with 67 over 36. So remember, it's going to be negative because they have the same sign, negative 67 over 36. Okay, now the grand finale. Are we ready? Yeah. Okay, so number 30, negative 8 over 9 minus parentheses negative 1/3 plus 3 over 4. Okay, let me try to write neat here. Yes, you're ready. You're going to be ready now. Hold your hands to the process. Okay, so order of operations. You're probably going to be tired of me saying that, but hey, that's all right. Okay, so parentheses. Let's deal with that first. All right. This is a fun one. Okay, work in the parentheses. That's here. So we have different signs, so negative and positive. So because we have different signs, we're going to take the sign of the larger number, which is larger? 1/3 and 3 over 4. Which do y'all think is larger, 1/3 or 3/4? What do you think? Anybody can type it or shout it. Ignore the negative. Which is a bigger value, 3/4 or 1/3?
3/4.
Perfect, 3/4. And the way they remember to kind of think about that, 3/4 is really close to 1, right? Close to 4/4. So we're going to keep the sign of 3/4. So it's going to be a positive, and then we have to subtract 3/4 and 1/3. So again, since 3/4 is bigger than 1/3, then when we subtract, we're going to say 3/4 minus 1/3. Okay? We don't want to say 1/3 minus 3/4. 3/4 minus 1/3. Okay, so to do that, we're going to get common denominators. Common denominator will be 12. So 4 times 3 is 12. So my equivalent fraction is 9 over 12. 3 times 4 is 12. So my equivalent fraction is 4 over 12. And so now we've got 9 minus 4 over 12, which is 5 over 12. So that's going to be in the parentheses here. Because again, we said that we're going to take the sign of a larger number, which is 3/4, is going to be positive, the difference, which is 5 over 12. So now let's bring down that negative 8 over 9 minus 5 over 12. And we really don't need the parentheses at this point, so I'm just going to rewrite it like this. So here's another example of we are subtracting, or we could look at it as adding the opposite. And they have the same sign, So we're going to keep that sign, and we're going to add 8 over 9 plus 5 over 12. Actually, let me write it up here. Let's make more sense to write it up there by it. Okay, so lucky for us, we already figured out the common denominator for 9 and 12. That was 36. 36, 36. And I'm circling that negative just to remind you where it came from. Same sign. So we keep the sign. This is for adding integers. Okay, so 9 times 4 is 36. So the equivalent fraction here will be 8 times 4 is 32. And then 12 times 3 is 36. So the equivalent fraction here will be 15 over 36. So now we have 32 plus 15 over 36, which will give us 47 over 36. So remember that answer is a negative 47 over 36. So that is my final answer. So let me look at it all together with you. Started off by combining in the parentheses. So we got a common denominator of 12. And the way we figured out how to subtract is because we had different signs. So the rules for adding integers of different signs, we take the sign of the larger number. So we thought about, oh, okay, 3/4 is larger than 1/3, so our answer is going to be positive because the bigger number is positive here. Then we take the difference between 3/4 and 1/3. So we subtracted 1/3 from 3/4, and we end up with 5 over 12. So going back to the original problem, that is coming from the parentheses. So now we have that we brought down the negative 8 over 9 minus now 5 over 12, which is what we have here. So now we have the same sign, so we are going to add them together. I did that in red, and we're going to keep the sign at negative. So I have that negative on the outside the whole time just to kind of symbolize that, not forget that. And so we now add 8 over 9 plus 5 over 12. We got common denominators, and we end up with 47 over 36. But remember, it's negative 47 over 36. Okay, so that was fun. A few things to remember. So your deadline for the midterm is, let me get my, did I leave my folder with the deadline? Okay, yes I did. Is it Monday? Pretty sure it's Monday.
Is that April 2nd?
Yes, next Monday. Thank you. Next Monday. Oh, thank you. You're exactly right. So I had to clarify that. Thank you for that. Yes. So, April 2nd is your midterm deadline, and I know your schedule was not clear. So I sent out an announcement about that. I'll do another reminder just to make sure y'all got that. I mean, if you took it early, it wouldn't kill you, but you would take away, study time. So April 2nd is the last day to do it, and it'll be available for you to take a week prior to that. So starting next Monday, the entire week, it'll be in the Osceola Testing Center for you to take on the computer. The same way the midterm review looks, that's going to be how your actual midterm looks. You can take, so I got a question about the deadline. So April 2nd is the last day. Let me write this down. April 2nd is the last day. I should type it, it'd be neater. So the deadline is April 2nd. But you have from next Monday, which is the 26th, I think,
Right.
all the way to the 2nd to take the midterm. So you can take it early. Also remember that the Osceola Testing Center closes at 9, so you want to get there before 7 p.m., whatever day you go, so you can get your full 2 hours in. You'll have 2 hours to take it, and then remember, no calculator. So just do yourself a favor and please, please, please practice without the calculator. And again, you can take this midterm multiple times. Your grade on the, not the midterm, I'm sorry, the review. The review you can take multiple times. So I'm sorry, y'all.
I was like, what?
I know, y'all, just bear with me. The review, I'm literally telling you this off the dome. I haven't written anything down. That's my bad. The review, you can take multiple times. The midterm, one time. So just, get to where the midterm review, you're like dreaming about it. Oh, I got a question. Hold on one sec. Yes, you can take the review now. It is available now to take. So you can take the midterm review now. Start now and do a little bit every single day. No calculator. Trying to think of anything else. If you haven't been to the depot, it's on campus, but great resource to get some extra help. My office is actually here as well, so if I'm in my office, you're welcome to stop by. And then there's online tutoring via a company called Smart Thinking that the college pays for, that you can access through your Atlas account. I think there's a link in the Blackboard course, but I've heard good things about that as well. And it's 24 hours, 7 days a week. So there's like little tutors in Smart Thinking land waiting to tutor you online. But I think that's it. So I tend to ramble, so I don't want to hold you guys too much. I've already held you like an hour over. Ooh, y'all are giving me allergy tips. Thank you. Y'all are the best. Okay, I'm going to write that down. I've never heard of that. I'm going to write that down. So I hope this was helpful. A lot of you are doing excellent with emailing me with questions, whether that's with the work or something that's not showing up in Blackboard, or I'm at the yes. Do not hesitate to contact me. I try to email you back quickly. It goes to my phone. Sometimes I write back like it's a text message, so do that. It's really important that as an online student, you aren't afraid to reach out to your instructors in whatever class that is. And your instructor should be replying to you at least within 48 hours, really 24 hours. And I know I try to, but definitely do your part and also hold them accountable. And you hold me accountable and just continue to contact me with any questions. But anyway, I hope this was helpful. It's been a pleasure. You guys have been great.
Thank you.
And just keep practicing. And if you have any questions, just reach out. And we can also, I can do this type of thing solo as well. So if you need some help, just send me an email. We can, if you can't make it to campus, we can schedule a time and we can maybe work for 20 minutes this way if that helps you. So I'm here for you if you need me. But happy studying, and I hope everything's going well in your other classes. So I will talk with you guys later.
Thank you. One question.
Go ahead.
On the test, is this going to be like multiple questions that we just select which is the correct answer, or do we have to work it out? Yeah, we work it out, but on the test.
The test is going to look just like the review. So that's another reason why I want you to practice it, because the setup is the same. You're almost taking the midterm almost, but it's not. But it's very, very similar.
Okay.
Yeah, because I know it's kind of different, typing the answer as opposed to writing it, so I want you to be comfortable with that as well. But it'll be just like the review.
All right. Okay.
All right. Well, thanks. I will talk to you guys later.
Well, thank you very much. You have a good day.
No problem. You too.
Bye-bye.
Bye.